Hi everyone, in this video I'm going to be showing a quick tutorial on how to use boundary constraints within Grasshopper WASP to bound your aggregations inside some sort of boundary. So within the package that you all have in the semester, I'm going to be using 003 aggregation constraints and then the 003 basic component aggregation bounding constraints Grasshopper file. So when you open up the Grasshopper and Rhino file, the Rhino file is going to look like this. So we're going to have a boundary box, and I'm going to be using a kind of boundary box that sort of starts to resemble the massing of a tower. In this tutorial, I'm just going to be using a basic aggregation just to show you the, so you get an understanding of the constraints. And then we're also going to be showing you how to use an interior bounding box, which I'll explain what that is in the Grasshopper. So we're going to go and open up Grasshopper, and basically the everything's basically the same in terms of your connection logics and your rule generator. But now what we've got here is a boundary part of the Grasshopper script, and then also obviously visualizing and aggregating still remains the same. So in order to constrain a geometry, your aggregations within a boundary, there's a couple of things we're going to need. The first is a boundary itself. So go back into Rhino, and I'll just call it a layer. We're going to be using this boundary. So the boundary that I have at the moment is about 30 meters by 30 meters and 100 meters tall. So we're going to be working off these proportions. This could be, boundary can be really anything, and I'll go into more complex boundaries later in this tutorial. So first thing we need to do is model our boundary in Rhino, and then we're just going to reference that boundary into this geometry container here. So I'm just going to set one geometry here. So just disregarding this part for now, we're just going to focus on everything that's in the pink group. Grasshopper has WASP has a component called WASP mesh constraint, and this basically means we can constrain the aggregation within a global constraint. So there's a couple of inputs here. The first one is our geometry that we're constraining it to. So this is the green box that we're constraining it to. Then the next one is it's asking for an in and soft value. So the in value basically means if it is true, it's going to allow parts only inside the box, and if it's false, it's going to allow only parts outside of the box. So basically, if it's false, the aggregation will only occur outside of this green box, and if it's true, the aggregation is going to occur inside, and we want it to be true. And then soft, basically, what WASP does is it's going to check as a method of checking how to know basically if your aggregation is inside the boundary box or not. So there's a couple ways. There's two ways it's going to check. If it's ticked true, then it's only going to use the center point of the part. So it's going to use the center roid of this component and check if the center point is inside the box. And then if it's false, then it's going to use the whole geometry. So all of the geometry has to be inside this box. And so there's different instances where you might use false or true, and I'll show you the difference. But generally, I like to have it on soft because if we're designing a tower, the massing is kind of a guide for where we want the tower to aggregate in, rather than a strict kind of boundary. And then finally, we've got two more parameters where we can constrain based on other constraints, which I'm not going to go into too much today. And then we've got a ID for constraining specific parts if we wanted to only constrain specific parts, but we're not going to use that too much today. So that's the basic WASP mesh constraint component. Now, if we just start, if we just start aggregating, you'll notice that it's going to start. I'll just hide this. Putting all these components inside that box. But one thing that's important is when we start to aggregate, our initial component has to be within inside our boundary. So we can't, if I just unplug this for you now, press, you'll see now without a previous position. So this input here, where we define a starting point or a previous point for the aggregation to start, it's going to throw an error, and it's going to basically tell us we could not place parts, because what's happening is the aggregation is going to start from here under this instance, and because we're setting up a global constraint where the aggregation has to be inside, immediately it's not going to be able to aggregate because we're starting the aggregation outside. So in order to do this, what we need to do is we need to move our geometry. So there's a couple ways we can do that. We can just manually move the geometry if we really wanted to inside. Or what we can do is we can get the volume of our basic component, and that will give us the centroid of that component. And then we can get the centroid as well of our massing. And then we can move that geometry into the center. Now, it doesn't necessarily have to be in the center of the geometry. We could also say move our geometry. Let's say we need to move it in the X direction. So we'll go X. And then we need to move it negatively. So we're going to go, say, 150, and we're going to change this snapping values. And we're going to say somewhere here, and maybe let's just move this. So we could start our aggregation also from here. So it's up to you how you want to move the geometry and where you want to place that initial start position, but ensuring that the component actually does start within the boundary is important. So the next thing we need to do is, in order for WASP to work, we need to basically convert that transformation. So that movement from this point into this point, we need to convert that into a piece of information that WASP can read. So in most move components within Grasshopper, you'll have a transform output where it houses that transform data. So we're going to take that transform data and we're going to use a WASP transform part component which you can see here. And we're going to plug that transform output into the transform input part. And then it also asks for a part. So we're transforming our original part, so the part that we've set up. So we'll plug that into here. And then what we can do is then go ahead and from part out, we can plug that into previous. And now if I click reset, you'll see that it starts to work inside the boundary. And I'm going to just get a silhouette for you so we can see the boundary. So that's our boundary there. So a couple things. If we can see, if I toggle soft, false, and then press reset, it slightly changes where you see now everything is really within the boundary. If I were to toggle true, false to in, and then you'll see everything is gonna happen outside of the boundary. So this, you can use global constraints as a way to sort of spatially organize on a global macro level how you want to the aggregation to occur. One thing I'll note as well is when dealing with global constraints, it's important in the aggregation engine under mode that we have, there's 3 different settings. So 0 is no constraints, when we're not constraining the geometry at all. 1 is local constraints, and I'll get into that a bit later. 2 is global constraints, and 3 is local and global constraints. So we want it to either be 3 or 2, so we can change that, but it's not going to make much of a difference. I generally just have it on at 3, and then we also want to ensure that our global constraints is plugged into our global constraints input in the engine. So that's in terms of inside global constraints, but the good thing about this is we can actually have more than one global constraint. So in order to do that, all we need to do, and I'm going to move this out for us, is we need to just have a merge component. So if you double click and search for merge, and the merging will just merge all our global constraints together. And so I'm going to have one basically constraint where it's constraining it within the geometry, and then I want another global constraint where I want the aggregation to not go inside, basically. So in this instance, if we're looking at the typology of a tower, this will be useful if I'm trying to do, say, the core of the tower. So I'm going to model, say, a 4 meter by 4 meter by 100 meter massing block. I'm going to change this layout. So that's going to be my core of the tower, and I'm going to move this into position, say somewhere here. So now I'm going to click set one geometry, and I'm going to plug this global constraint into the merge component, and don't worry if there's a D3 that comes up. So I want now the parts of the aggregation to be outside of this component, so I'm going to click false. I'm going to click false as well to soft, so that the geometry isn't going to intersect. We can have it as true as well. It's going to change a little bit the type of aggregation that we can do, and we'll see what that looks like once I start aggregating it. So I'm going to press reset now, and so you can see here now we've got some interesting core happening. And if I click link plane this, yeah, you can see that's where the core is, that constraint, and it's consistently changing through the tower's plan and section. So if we go to the section, so you can see there now that we've changed the interior of the tower. And I'll just show you, if I click true to soft and then reset it, it's going to change the aggregation slightly, where basically we can just it's going to, the core is less visible. So generally we want to have this on false. So that's a good way of setting up not just the core and the larger macro field, but then what we can also do is we can do some interesting things, like we could say take a sphere, we could copy this, and let's clear this value, and we'll set one geometry here, and say I want a particular void in a section of the tower. So maybe it might be here, and let's put that in here, and then we'll, so now you'll see if I hide this, that it's kind of I'm shaping the tower. So you can see if I start to move this and reset, I'm gonna just delete the clipping. So we can see that it's creating some sort of interesting voids and spaces within that tower. So, and what I can do is I can, manipulate this geometry as well. It doesn't have to be a sphere. I can start to play with that geometry, and that's the cool thing about this is it allows for different types of mesh geometry. So you can see now we're starting to manipulate the macro form of the geometry using these kind of global constraint methods. So that's something that's quite fun to do. So you can see now I've just carved a large portion of the tower, and this also can be applied to the larger macro tower as well. It doesn't necessarily always have to be a box. So I can say, well, maybe I want this to come out a little bit, and then I want this to come out a little bit. Now if I change this, the tower is gonna be a little bit different in terms of its typology and its placement. So that's basically just a quick rundown on what a global constraint is. It's quite useful in terms of setting up the larger macro scale of your towers. We'll see you in the next one.